Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Hairul Iskandar bin Hairul Nizam. So I and my friend Muhammad Khairul Zihani bin Kelana and Muhammad Akram bin Roslan will explain to you about photolithography. Alright, basically photolithography is the process of transferring geometric shape on a mask to the surface of silicon wafer. The steps involved in the photolithography process are wafer cleaning, barrier layer formation, photoresist application, soft baking, mask alignment, exposure and development, and also hard baking. So we will explain more detail in the demo. Alright, let's we go.
Okay, hello everyone. Today I would like to present a scratch coding about presenting about my scratch project, which is photolithography. Okay, first, what we have to do in coding the codes for scratch for this project is we have to decide the background, stage, or backdrop. So first we have to include the stage or backdrop, and then after that we have to upload a sprite like in the slide, like the like a woman like the woman in the purple shirt. And then first we put the when the green flag click in the code, and then we put looks codes, which is hide, so that this when the green flag clicks it will hide. And then the sprite will go to a coordinate, and then it will show, and then for 5 seconds it will hide back. So next sprite, the coding was the coding is when the green flag clicks, we drag hide looks code, and then wait for 9 seconds. It will show. This is the algorithm we put in the pseudoscode, and then the sprite will say hi, say how is this possible for 2 seconds, and then the sprite will go to the position stated there, and then it will think him for 1 second, and then you will see it is photolithography. So this is the algorithm for the pseudocode. Next sprite is a little bit different because we have many costume in one sprite. It is a sprite, but we have many costume. We have costume A, B, C, D until G, and it shows different character, different structure of the sprite in order to make the sprite move. Looks like moving, looks like it's a mobile sprite. So when we put when the green flag click, and then we put the looks coding height, and then when the timer is more than 106, we'll have the loop here. We have a loop forever and wait. This is the ready-made loops at the scratch, and then this loop it will it will looping for forever, when the time is more than 106. So the sprite will show, and then it will switch to costume 1 or costume A.
Cell phones, computers, televisions, and any high technology product requires the use of printed circuit boards, microcontrollers, or integrated circuit IC. How are they made? The components of this device are extremely small if they are too small to be seen by our naked eyes. How it is possible? These products are made using a technique called photolithography. Photolithography is a process that transfers shape from a photomask to the surface of a silicon wafer using light. Alfonso Putin was the man who invented the process that's still used in the modern micromanufacturing today. He did this in 1855 by combining light with lithography. The modern process that is used today requires many steps and several different tools and chemicals. The silicon wafer is treated chemically with hydrogen peroxide to remove any contamination that may be presented on the wafer. Contamination may come from the removal of wafer from the pots and they are transported in or from the robot arm which the wafer sit on. Then a layer of silicon is placed on the wafer to act as the masking film. Hexamethyl diacyl is N or HMDS is placed on the wafer to increase adhesion of photoresist to the wafer. This reduces the amount of resist needed in the coating process and is referred to as our RC reduced resist consumption. Wafer is covered with photoresist by spin coating. Photoresist is dispensed onto the wafer and the wafer is spun rapidly to produce a uniform thick layer. The spin coating typically run at 1200 to 4800 rpm for 30 until 60 seconds and produce a layer between 0.5 and 2.5 micrometers thick. Run off from the extra photoresistor removed to a process called 8-bit removal. To produce a flat layer of resist, the photoresist coated wafer is in pre-bake to dry off excess photoresist solvent. A mask that resembles the chip geometry is held above the resist coated wafer. UV light of extreme intensity is directed downward through the mask onto the wafer. This causes a chemical change in the photoresist that is exposed the light by the mask.
The photoresist is baked to drive off solvent and to solidify the film. Soft bake are commonly performed on hot plates or in exhausted ovens. The range of temperature of typical soft bake process is from 90 degrees Celsius to 110 degrees Celsius. Soft bake must be optimized to provide complete removal of solvent at photoresist or substrate interface. The major cause of adhesion failure during wet etch or plating is the retained solvent at the photoresist and substrate interface. Post-exposure bake or PEB is the process to smooth rough feature sidewall caused by standing wave characteristic of thin film interference in a monochromatic exposure process. This process is very important that skipping PEB will result in no or a very faint pattern after develop. In both type of photoresist, PEB improve adhesion and dry etch resistance since more solvent is removed from bulk film. Then the hard bake or post-developed bake at the photoresist pattern is a common method for stabilizing the printed feature to provide optimum performance at etching. This final bake step ensures complete removal of solvents, improving adhesion in wet etch or plating process, and resistance to plasma or RIE etches. Hard bake degree should equal or not more than 5% higher than post-exposure bake temperature. The delay between hard bake and etching should be reduced to prevent rehydration of substrate and resist.
In general, the bright field inspection system is intended for the detailed examination of pattern defects. For example, the first quality check after the photolithography process is performed after developing and baking, or checking the pattern misaligned surface problem, for example, contamination, holes, lines, and distorted pattern. If the if the wafer passed the inspection, it will go to another process area. If a wafer didn't pass the quality check, it will rework to photoresist remove. Evolution of photolithography. Has the technology improved? How photolithography has improved from 1855? What we call that Moore's law. Moore's law states that number of transistors double in 2 years. Smaller resolution allows higher density of transistor in IC integrated circuit. This allows higher capability of computer processing with smaller components. With that, thank you.